For a long time, it's been very straightforward to take temperature measurements of the air and sea. But how do we measure historical temperatures? While many proxies like carbon-13 have already been discovered, one new approach is to measure the oxygen-18 content in corals, providing past data on ocean temperatures. Fundamentally, delta oxygen-18 tracks sea temperatures inversely, increasing in abundance with lower ocean temperatures as glaciers store a disproportionate amount of regular oxygen-16 relative to oxygen-18, since the former is lighter and hence quicker to evaporate from water and be stored in ice as frozen over precipitation. Such an event is an example of kinetic fractionation that occurs in a unidirectional way, given the relatively constant amount of oxygen-18 on Earth even over longer geological time periods. Bivalve shells that form the exoskeletons of mollusks are a good tool to start with, but it was only until recently that its oxygen-18 content has been able to be calibrated among various species in disparate regions among the world's oceans. More specifically, clams are stained with calcium to track growth increments that occurred after a certain period in time. Coupled with the knowledge of oxygen-18 precipitating in isotopic equilibrium with seawater, variations in delta oxygen-18 in shell structure can be aligned with ocean temperature fluctuations, both over the short term, through lower values in the summer and higher values in the winter, but also longer-term variations over the clam's lifetime that evidence human-led climate change.
Bivalve shells can also map other climate phenomena, like the El Niño Southern Oscillation, because of their presence among so many types of clams and mollusks that are widespread across the globe. In this case, the shells of Donax obisalis, a type of clam found off the northern coast of Peru with a short lifespan, are used. We stain these organisms with a calcium, a fluorescent chemical, to visually track growth. For corals, though, they have density-based age bands, allowing delta oxygen-18 values to be matched with the specific year in which that coral growth occurred through a linear regression analysis. Yet measuring the delta oxygen-18 through the exoskeletons of mollusks and corals has downsides, such as the potential to be influenced by other environmental factors like calcification and dissolution. Nevertheless, the method's ability to test many different species with calcium carbonate shells can be compensated for, as scientists find other specimens in the area to fill in gaps in the oxygen-18 record. Ultimately, measuring delta oxygen-18 values in calcium carbonate exoskeletons as opposed to older, more conventional methods involving ocean floor sediments provides an alternate method of tracking sea surface temperatures that could fill in gaps in the historical record. In the midst of many drastic weather events due to climate change, it's important to have strategies based on scientific data, like tracking sea surface temperatures, so we can provide strategies for risk mitigation to some of these at-risk communities.